this was the last exercise from the previous class. It was about conditionals, conditional statements, and yeah, let me rewrite it here. Just a second. Okay. It says, if the moon is flat, if the moon is flat, then Pisa is not in Italy. Then Pisa is not in Italy. Okay, last week we were studying conditional statements, and this is the conditional statement because this is a complex statement that consists of two parts. The first part is if part. In this case, it's the moon is flat. Let me denote it as A. And the second part is B. Let me denote it as B. And what we have here is we just have the conditional statement, if A, then B. Okay, anytime you have conditional statement, you should know that contrapositive of the conditional statement is also true. Whenever this one is true, but we are assuming that this is true, so the equivalent for the conditional statement, it's called contrapositive statement. I will write it with red. Contrapositive. Positive. In contrapositive, what you do, you just swap A and B with places, and then you negate them both. So you have if not B, then not A. Okay, every time you have conditional if A, then B, this is 100% equivalent to if not B, then not A. So I will as well note it like this. And now we can just replace, instead of B, instead of A, we can again put a sentence back. Previously, B was Pisa is not in Italy. Okay, B was Pisa is not in Italy. Now, not B, now is, you have to negate Pisa is not in Italy, you have to add not. So it will be Pisa is not, two nots cancel out, and now you will have just Pisa in Italy. Pisa in Italy. So this is not B. B was Pisa is not in Italy, not in Italy. Italy. It was already negated statement, and then you negate it twice, and negation cancel out. Okay. If A was the moon is flat, then not A is the moon is not flat. So finally, you will have if Pisa is in Italy, if Pisa is in Italy, then the moon is not flat. Is not flat. Okay, you have any questions here? Just remember, anytime you have sentence, I recommend you, I suggest you to, you have to shorten this sentence. How you shorten, you just replace some, sentence with a variable. In this case, we replace the moon is flat with A and the pizza is not in Italy with B. And then we can easily work with this conditional statement and solve further. Okay, this was the first exercise on conditional statement. Now we will see the second one. The second one was a little bit harder. If I'm not wrong, it was about mass problem. Just let me see it, if I can place it here. Yeah. Okay, second one, it was if two functions are differentiable, then their product is also differentiable. Okay, anytime you have statements, you can either take some conclusion from the statement, or you can, find negation. In this case, we have, in the question we can, it's written, right here, it's written, we can deduce that. So we can deduce that is the same as we can conclude that, and so on. Anytime you have such questions, you have to find equivalent statements. So in this case, you need to find the equivalent statement for this. If two functions are differentiable, then their product is also differentiable. Okay, now I'm a little bit lazy. I don't want to rewrite it here. I will just note it here. Okay, if two functions are differentiable, I will denote it with A. If two functions are differentiable, this is the same as A, and their product is also differentiable. There, it means the product of two functions. The product of two functions is also differentiable. It will be B. So what we have here, now we have if A, then B. Again, we have this conditional statement, and we need to find equivalent statement. In this case, equivalent statement, whoop, where is my rectangle? Okay, in this case, equivalent statement for the conditional statement is again contrapositive one, contrapositive. And again, to find contrapositive from conditional statement, you just swap B and A with places, and then you negate them both. It will be if not B, then not A. So this is our contrapositive statement. And now what we need to do, we need to again, go from letters to sentence. So if B was the product of two functions is differential, no, the two functions are differentiable was A, okay. B was their product is also differentiable. Their product, it means the product of two functions is also differentiable. Okay, if B was their product is also differential, we can rewrite it as the product of two functions is diff. I'll write this as differentiable just to shorten a little bit sentence. If B was like this, then not B, the product of two functions is not differentiable. If B was the product of two functions is differentiable, not B is just negation of this. What you can do here, you can just copy this. Okay. Let's put it back here. The product of two functions is, in this case, we have to add not in front of differentiable, is not diff. So we will use not B. Okay, if A, in our case A was two functions are differentiable. Two functions are differentiable. Okay, if A was two functions are differentiable, maybe you can think that, maybe you're assuming not A, two functions are not differentiable, but this is wrong. Guys, anytime you have, numbers, for example, 2, you can replace like all functions are differentiable. It's the same as two functions are differentiable in our case. And to negate all, you just need to find one contradiction. In this case, it says two functions are differentiable. If you tell me, negation of two functions are differentiable is two functions are not differentiable, this is wrong. Why this is wrong? Because negation of the sentence is at least one of the two functions, at least one of the two functions is not differentiable. Okay, let's say you have two functions. This is function 1 and this is function 2. A says that function 1 and function 2, they are both differentiable, both diff. But not A, to find not A, if you remember, we use De Morgan's law. And in this case, the same, you are using De Morgan's law. You need to contribute not to F1 then not to F2, and then to OR. And you'll have just either function 1 is not differentiable or function 2 is not differentiable. And OR is the same as at least one of two functions is not differentiable. All right. And the final statement, what we'll have here is, we'll have if, here it's already written, if not B, then not A. Okay, if two functions, let me copy it from here. So not B was this one. Not B was if the product of two functions is not differentiable. I'll just put it here. If the product of two functions is not differentiable, we just add then. Then, and I'll copy not A as well. If A was two functions are differentiable, not A is at least one of the two functions is not differentiable. So this is the final answer. I'll just denote it some green. If the product of two functions is not differentiable, then at least one of the two functions is not differentiable. Okay, let us search for the right answer. Okay, A, all product two functions are differentiable. If the product of two functions is not differentiable, then at least one of the two functions is not. Okay, in this case, the right answer is C. All right, you have any questions here? If not, we can go and continue to solve next one. Okay, no questions. Okay, this is quite simple exercise. I think most of you already solved it. It says, it is not true that it is rainy and it is windy. Okay, I will write. In this case, our statement is it is rainy and windy. This is our statement. It is rainy and windy. This is our statement. And before our statement is written, it is not true. Anytime you have it is not true or this statement is false, something like this, they are asking us to negate the statement. We have to negate the statement. We have to contribute negation. All right. In this case, how do we do it? Usually what I do, I just, shorten this part. I write A as it is rainy, and I write B as it is windy. So our statement is it is rainy and it is windy. This is our statement, and what we do is we are contributing not, and here we just simply apply De Morgan's law. Many times you already heard about De Morgan's law, is contribution of not into the brackets. So you not only contribute not to variables, but also to the word and. So this is the same as not A or not B. Okay, whenever you contribute not into the end, it becomes or. So this is our final answer. And if A was it is rainy, not A is it is not rainy. It is not rainy, or it is not windy. So this is our final answer, and let's search. We have something like this. It is not rainy or it is not windy. In this case, A is the right answer. Have any questions? Okay, we can continue going for the next one. Next one a little bit harder. It was the question on statements. How many of the statements true? And in this case, you need to find the true statements. All right. To search it a little bit here. No, I didn't copy it. Let's go back. Okay, here it is. Okay. In this problem, there is Anna, Bruna, Claudia, Davide, and Eva. There are 5 friends, and every one of them have their own statements. For example, Anna has statement, "I have green eyes," and this statement can be either true. Let me denote it here. It can be either true, T, or false, F. Okay, and every of those 5 statements can be either true or false. Okay, in this case, they are asking us how many of these statements are true. Okay, first thing first, you need to realize which of the statements we can solve by ourselves without logic if there is some mathematical problem or there is something that there is some fact. For example, in this case, Bruna states the square of an odd integer is odd. Is this true or false, guys? What do you think? She's telling us we are taking the odd numbers and we square it, and the result is also odd. Someone wrote to the group. Yeah, this is true. For example, if you have 3, 3 is an odd number, and then you square it, you will have 9. For example, you have 5, it's an odd number, you square it, you have 25, and so on. All odd numbers, if you square them, they will be also odd. So we already found one true statement. Let us denote this statement as true, true. Okay, which statement also we can calculate? For example, if you go for Davide, there is some, just a mathematical problem, we can calculate it. And let's check if it's true or not. It says 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 3 plus 2 to the power of 4 is equal 31. Is it true or false? Okay, 2 to the power of 0 is the same as 1, plus 2 to the power of 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the power of 4 is 16, and let's compute 8 plus 16, 24, then 28, then 30, then 31. So in this case, the statement is true. We already know that two statements are true. All right, you can already eliminate D because we already know that 2 statements are true. Then what we have here, Claudio says only one of the statements of my 4 friends is true. This is in this case false because we already found 2 true statements. It will be false because Claudio says only one of the statements of my friends is true, and this is false. All right, and let's check Anna and Eva. In this case, Anna and Eva, we cannot tell for sure which one of them telling the truth and which one of them telling the lying. For example, Anna says, "I have green eyes." And Eva says, what Anna says is false. Can we assume that Anna telling the truth or she's lying? Not. But we for sure know, in this case, we for sure know that Anna and Eva we for sure know that they cannot, they cannot be at the same time truthful. For example, Anna cannot tell the truth and Eva at the same time cannot tell the truth. Why? Because there is contradiction. For example, let's assume that Anna, telling the truth, and she says, I have green eyes, and this is the true statement. And then we go back for Eva. Eva says, what Anna says, it's false. Let's assume that Eva is truthful, that this is true. If this is true, then Anna lies, but Anna already telling the truth, right? So they cannot tell both truths at the same time. So let's assume that Anna is telling the truth. Anna says, I have green eyes, and this is true. And Eva, in this case, her statement is false. She's telling what Anna says is false. And we are assuming that her statement, she is lying. And in this case, what we have here, we have 3 true statements and 2 false statements. But what we can do here, we can as well, do vice versa. Let's imagine that I have green eyes, she's lying. This is false. No, first let's go for here. What Anna says is false. Let's assume this is true. Let's assume Eva is not lying, she's telling the truth. She says, Anna says, what Anna says is false. Then we go for Anna, and we know that Anna is lying already, and this is also, consistent in our case. And what for sure we know that we have three true statements and 2 false statements. But in this case, they are asking how many of these statements are true. And in this case, this is 3 statements is true. All right, you have any questions here?
No.
Yeah, let's go for the next one. Okay, this exercise was on necessary and sufficient conditions. And yeah, here what you need to do, you have to go from necessary and sufficient, you have to go to conditionals, the normal conditionals. And let us try to solve it together. Okay, what it says patients afflicted by a certain disease can have 3 symptoms. It's either X, Y, or Z. To have symptom X is necessary to have symptom Z, and sufficient to have symptom Y. All right, here we have the words necessary and the word sufficient. From those 2 words, we can assume something. For example, our second logic class was on those 2 words, on those 2 conditions, necessary and sufficient, and we'll see, maybe you'll recall something from our second lesson. All right, in this case, it says X is necessary to have symptom Z. So what we can assume here? We can assume here that it is necessary to have symptom Z. Okay, we can assume that Z is necessary condition for X. Do you agree with me here? If you go back here, it says to have symptom X, it is necessary to have symptom Z. So in this case, that is necessary condition to have symptom X. Symptom Z is necessary for X. We get to write R. Okay. Second one, it says Y is sufficient for X. Okay, in this case, Y, this is the sufficient condition for X. The word sufficient, usually I replace with enough, and it's easier to associate with. Okay, in this case, Z is necessary. Let me not write condition. I'll just write Z is necessary for X. For X, how can we what kind of conclusions we can have from this necessary statement? Anytime you have necessary statement, you can have two conclusions. That Z does not guarantee X. This is the first one. And the second one, we can write, if not Z, then not X. Okay, for example, let's associate this with something. For example, in order to get admitted in Italy, you have to pass TOLC exam. So TOLC is necessary for getting admitted to Italian university. And how can we convert it to conditional statements? We can say, if you don't pass TOLC, then you will not be admitted to Italian university. So whenever you have necessary condition, you can relate it to conditional statement, which is if not Z, then not X. This is the first case. The second case is that from this we can go to contrapositive. We can go if X, then Z. If you have X, then you have Z. Guys, do you remember from the first exercise of today that this is our conditional statement, conditional, and whenever we have conditional statement and we are assuming that this is true, the contrapositive in this case also true. In this case, this is contrapositive. We just swap them, places. We swap X and Z with places and we negated them. And we have double negation, and negation, not there, cancel out, and we have this condition. And we can go back from if X then Z, we can go back here. We can swap the places. It will be if Z then X, and we can negate it. It will be if not Z, then not X. Okay, now we have those two conditions. This is, basic things that we are assuming. Anytime you have sufficient condition, anytime you have Y is sufficient for X, you can rewrite it to if Y, then X. It means that Y guarantees X. If Y is true, then X is true. So you have only one assumption, one conclusion from here. If Y, then X, and here you have two conclusions. And let's imagine, for example, let's imagine that we have symptom Y. If we have symptom Y, then we have symptom X. But from this case, if we have X, then we have Z, right? For example,
Yes.
let's imagine Y. If we have Y, then we will have X. But if we have X, it means that we will have Z as well. So this is the chain of symptoms. If you have Y, it's sufficient. If you have Y, it guarantees that you have X. But if you have X, it guarantees that you have Z. And in this case, this is the right answer. Let's see if you have something like this here. Okay, in this case, E, it says any patient that has Y also has X and Z. This is the same as if someone has Y, then it has X, then it has Z. So Y implies Z and Y implies X. Right? You have any questions here?
No.
Okay. Let's go for the next one. Okay, this was quite hard exercise. Also, I spent quite a lot of time to solve it. And actually, was this exercise that you couldn't solve? All right. Yeah, we'll see.
My answer was C.
See, Bruno is telling the truth. I will not tell it the right answer in advance, but I just want to think. I just want to make other think on this exercise. Okay, it says there is three friends. It's Ada, Bruna, and Carlota, and they are discussing. Yeah, which one of them telling the truth? And this is quite similar exercise to the previous, to this one, but in this case, we don't have facts. We don't have something like mathematical or something that we know. In this case, we need to use logical reasoning to find out which one of them telling the truth and which one of them is lying. Okay, I'll just rewrite all statements. For example, other, the statement of other that Bruna lies. Okay, other says that Bruna lies. Then Bruna says, okay, statement of Bruna. Bruna says that Carlota lies. Carlota lies. Then Carlota says that both Ada and Bruna are both lying. Carlota, in this case it's 2T, Carlota. Okay, I'll just a little bit rewrite this statement. In this case, it says Ada and Bruna are both lying. I'll write Ada lies and Bruna lies. This is the same actually. Okay, now what we need to do, we need to actually check all 5 possible choices. In this case, let's go for A. In the A, it says Ada and Carlota are telling the truth. Now, what we need to do, we need to assume that first statement, the statement of Ada is true, and the statement of Carlota is true. Okay, you see any inconsistency here? You see any contradiction here? Can they both at the same time tell the truth? If you go for the statement of Carlota, Carlota is telling Ada lies and Bruna lies. We are assuming this true. Now Ada lies, this is true. Then we go back for Ada, and Ada says Bruna lies. But we know that Ada is telling the truth. But in this case, Ada lies here. So there is inconsistency. Here Ada lies, I will write false, and here Ada is telling the truth. There is inconsistency. So we need to assume that Ada and Carlota both cannot tell the truth at the same time. All right. Someone wrote to the group. Let me read it. No. All right. Okay, we are eliminating A. Then we'll go for B. Bruna and Carlota are lying. Okay. Now we need to make them false. Okay, statement of Bruna, Carlota lies. Now it is false. Carlota lies, it's false. It means that if the Bruna says Carlota lies and we know that Bruna lies, then this statement becomes Carlota. I should write Carlota is telling the truth, but I'll just shorten it and I write Carlota and T. Carlota is telling the truth. Carlota T, all right. Now we go for Carlota, and we know that Carlota is also lying. So the statement of Ada lies and Bruna lies is false. How can we make this statement false? So the statement Ada lies and Bruna lies, we need to contribute negation, and it will be, in this case, let me write Ada is A, and Ada lies means not A. Okay, and Bruna I will write as B, and Bruna lies as not B. All right, we need to contribute negation because we know that this statement is false. And yeah. We are contributing negation here. And what we will have here, we will have A or B. All right, you see any inconsistency here? we already denoted that Bruna, the statement of Bruna, Carlotta lies, is false. Then Carlotta is telling the truth. Then the statement Ada lies and Bruna lies. All right. In this case, by assuming that Bruna is telling the false, then automatically the statement of Carlotta becomes the true. But here what we have, that Carlotta is lying. You see here, there is inconsistency. In the Bruna statements telling that Carlotta telling the truth, and the Carlotta actually is telling false, because we need to assume that Carlotta is lying. So there is another inconsistency, and B is also wrong. All right, let us go for C. We have less than minutes. Let's have 10-minute break.